Hi everyone. Let me introduce myself once again. My name is Aistė. I love questioning things, and in fact I do that for a living by testing. And by now I have gathered quite some experience in projects and product development, working on my own and leading teams, working with manual testing and test automation. And currently I work in Visma's biggest project, where I lead so-called technical testing, where we do test automation, performance testing, security testing, things like that. And in this project, for the first time, I got to think about continuous delivery. Probably our smartest guy in that project once said, actually, I think we have continuous delivery. We have one-click deployment to any environment, and we have test automation. And I'm sure he was kidding. Because technically, we can deploy often, but how do we know at any given point in time that our system actually works well with so many changes that we have? And it's actually exactly testing that answers that question, which is my field. So this is kind of my new passion. I've been looking into how others are implementing continuous delivery and introducing little changes to our testing as well. And today I will try and share my findings with you. I will not spend much time on what is continuous delivery. By the way, we heard about it today and its benefits, but I will use a couple of slides just to make sure we are on the same page. And then I will present quite an extensive list of example companies that are doing continuous delivery, just to have a taste of what I'm talking about, what I've been looking into. And then I will concentrate on testing, which I think is the biggest challenge of continuous delivery, and we will see why and how it can be solved. And the bonus part of this presentation is gifts at the end, so don't run away quickly. I know it's the last presentation. So we will see that later. And the most popular definition of continuous delivery is producing valuable software that can be deployed anytime. Others measure it in how many times they deploy per day or month, and it looks kind of cool, but what matters is the value of continuous delivery, and the value is twofold. So one, we shorten the time it takes for an idea, be it a new feature or a bug fix, to reach the actual users. And what that short time is depends. Some deploy once per sprint, some deploy many times per day. When they deploy many times per day, usually they deploy unfinished features that are hidden from users. And they do that to benefit from the second value, which is reduced deployment risk. So when your changes are small, each of them brings little risk, right? I've visualized the benefit of continuous delivery with Eurosign because this is what we get in the end, okay? And this colorful thing between the idea and the benefit is the actual software development lifecycle, and it's shortened to the extreme here. And this for sure means cutting corners. And to compensate for those cut corners, we have to take additional measures. And that's why not so many companies are doing continuous delivery yet, because you have to do quite some changes. And before I move on, let's learn a little bit about you. So who here does continuous delivery? Quite a few people. Who here think they are quite close to it? Okay. And who would like to do it? Why are you here then if you're not so many of you willing to do it? Okay. It would be real interesting to discuss later on, before the conference ends, after this, what you achieved that is really great, or what you think are actually the biggest challenges. Now, I've looked into how some well-known companies have implemented continuous delivery, and life is fairly easy when you're small, so I've looked into more complex examples, and I've learned really a lot, and I find myself using some of it in my project. And I will only have time to share the tip of the iceberg with you. But if you bring back one thing that you try, it will have been a useful time, right? So let me introduce these companies, even if from the logos you can see they require little introduction. Facebook is a giant, and each single person in Facebook is motivated to test well, because 60 minutes after the code is pushed, your boyfriend, your girlfriend, your mom can actually see what you did. Google is, they have multiple products with multiple delivery models, and even Google Chrome, which is not even a cloud solution, they actually have arrived to using continuous delivery. And Gmail apps, they are a very interesting example on how to make your continuous life easier. I guess you can see why. Then Spotify. Spotify are advertising their way of working very well with talks in various events and pictures like this. But actually, even they have devils in the details. Then an example of a company that has a head office in Lithuania, Vinted. They do really impressive around 300 deployments per day. And LinkedIn, they have once gone through 2 months of development halt to migrate to continuous delivery, only to find that when they kept growing, their process didn't scale and they had to do changes again. Etsy, I didn't know anything about this company. They are actually, if you don't know them either, they are a handmade stuff and vintage stuff marketplace. I found them when I started looking up good examples of continuous delivery. They're really proud of what they do, and they share lots of useful information online. Airbnb, great place to rent a place to stay. They don't do continuous delivery yet, but they are close, and they are a very good example of where to start. So for them, it was a group of interested people trying to lead by example, and they succeeded. And finally, Visma. We have also multiple products, and some of them are already doing continuous delivery, and we are taking steps to do that for more products. And Visma School is one of them, and this is the product where I work. And we are in a quite good position because we have had automation from the very beginning, and we have this one-click deployments to every environment. But it's still a long way to go, and I see a lot in common with what others had to change, and a lot of that is related to how to enable efficient and sufficient testing. And it's a very hard thing to do because testing is not fast. It takes time, and it's really hard to learn how to make it run not in months, weeks as before, days, but in hours or even minutes. What we want to do here is, to me it looks a little bit like having the cake and eating it too, because think about it. Test automation can never fully replace manual testing. Okay, you have automated tests, but what kind of tests you have? Will they find functional issues, visual issues, performance issues? So manual testing, including regression testing, has its value. Of course, the more automation you have, the more safe you may feel, but then the more tests you have to maintain and keep up with fast system changes. So are we then sacrificing quality? Well, with little changes that you deploy in continuous delivery, you have little risk. But these changes add up, so who is going back and testing the big picture? I'm saying testing takes time. How much exactly? Here is an example, continuous delivery pipeline. And testing, well, steps could be different, but usually it will look quite similar to this picture. And here you can see testing happens 3 times. So first of all, let's say we do manual exploratory testing. Then after we merge the trunk, we do run our functional automation. And finally, we deploy to stage where we do performance and security test, for example. So without looking at all other boxes, just these 3, how long do you think they take? Just think to yourself, let's look a little bit deeper. So here are the same 3 boxes, and it's quite hard to time box manual testing, but our changes are small, So it shouldn't take long as we don't have to do manual regression testing. So let's say it takes between 10 minutes to 1 hour, but that's only if our tests are successful. If not, we go back doing bug fixing or even to design if we have open questions. Now, automation usually takes a predictable amount of time, but predictable doesn't necessarily mean fast. So we know end-to-end tests are slow and unit tests are fast, but they tend to miss bugs. And we probably have a combination. Let's say we manage to run that combination of tests in half an hour. But that's also only if our tests are successful. If not, we go back doing bug fixing or test maintenance. Finally, we deploy to stage where we run performance tests and security tests because it's important for our system. And to keep up with continuous delivery pace, we will probably want to cut some corners here and do what we can within 20 minutes, doing more extensive tests a little bit less frequently. So you can see these 3 boxes, they're small, but they take a fair amount of time, and you have to squeeze them like sponges to make them smaller, but every sponge expands when you release it. So actually, to make it really work, you have to be smart about it. And here we come to the gist of the presentation, and I will start with things that are quite obvious. So this is not obvious in every organization, but now we run in an Agile community, so hopefully you're doing this, most of you. The main point is testers should be involved in grooming, planning, development, so they know what has been developed and why, and what tests have been added by developers, and maybe influence that. And when the feature is ready, testers should be also ready and test as quick as possible. Another thing that is quite known is developers, when they are pushed for velocity, they tend to rely on testers to find even obvious bugs. So then we end up in a ping-pong loop of bug fixing, redeploying, retesting, and we lose a lot of speed. So what I expect developers to do is not only write unit tests, integration tests maybe, but actually open the system and check some obvious scenarios, easy scenarios, so that when they push to test environment, it doesn't at least immediately fail. Okay, it can be taken further with developers. So a lot of developers feel they are done when they finished coding and unit testing maybe. But Facebook, LinkedIn, Visma Advisor, they have a little bit different culture. So you as a developer are responsible for your code forever, throughout testing, deployment, and supporting it in production. And this works miracles because suddenly developers start caring if their code is well tested, including regression tested. And sometimes they even start adding their own tests in their own language, even if testers usually add functional automation. This is what's happening at Spotify, and it's a great thing. The only thing to remember for continuous delivery is test duplication is also not so great. Another good thing that happens if you have this culture is developers also start caring about different environments, different configurations, and logging and monitoring also get additional love. There's only one issue with this. It's not always clear who is responsible when something happens, because stuff changes. Sometimes multiple developers work on the same functionality. So what LinkedIn does and what we do in Visma School, we try to maintain a list of defined responsibility for pieces of functionality so that we always know whom to contact. And this is not an easy thing to do, but actually it really does help. Then branching, it dictates kind of the way we test, and that's why I have to mention it. The most companies I've looked into, they have evolved to use metrics of services, the last one, But this is not where they started, and in fact, these models work well in a particular environment and not so great in a different one. So centralized is when everyone is working on the same branch, and you find and fix problems fast, and is the most straightforward way to test. But if you have a bigger team, when build breaks, it blocks work for others. So at some point, it becomes unacceptable. An opposite approach is for everyone to work on their own branch, to test on the same branch, and before release to merge everything into one, and then test this merged version again. And this is fine as long as it works. When it doesn't, it's hard to isolate the problem and fix it quickly. So there's a hybrid approach when you have these separate branches, but you merge as soon as possible and test immediately after that. And this looks like a fair solution, but even this one doesn't scale forever. So that's when you probably don't want to have a monolithic system, but break it into separate services that can be deployed independently. And this is first of all architectural change, but what does it mean for testing? So of course you have to test services and their integration with each other, but then versioning actually comes into play. So this is quite a complex approach, but well, it gives you pretty much indefinite scalability. Anybody here using this approach? Zero. Okay. I would say the key to successful continuous delivery is good test automation. And good can be defined with two properties. One is you can run your tests fast. Two, you can trust them, both in coverage and in results. And it's a very hard thing to do, even if it doesn't sound like rocket science. And sometimes even fast and reliable are two conflicting interests. But there are some things you can do to make your life easier, of course. So first of all, what can we do to make our tests fast? What I say to my team, and I learned this from Spotify too, it's good to have a goal. So time box your automation. See how you can test your system best in the given time frame. And for that, you might need to do some changes, and part of those changes can be test optimization. So you can think of things like, do I really have to log in every time before each test? Do I really have to create test data every time and clean up? Maybe I can do it faster. Maybe I don't have to test this thing through a UI. Maybe it can be a unit test. Just by concentrating on test optimization for like 3 weeks in Visma School, we saved like 25% of test runtime. Another thing that really impacts test runtime is the actual infrastructure. So we had come to a point when our whole test suite wouldn't manage to run nightly. And it turned out that the actual test environment was slow, needed to be upgraded, TeamCity and Stash needed to be upgraded, and the test start time could be changed not to interfere with other projects. Now Vinted, they do like 300 deployments per day, right? How do they run their tests? It turns out they invested in super powerful machines for Jenkins, etc. And now they can run their tests in 3 minutes instead of 1 hour. But of course, you cannot make your tests 20 times faster just by adding hardware unless you run them in parallel. So what we did is split our tests into 14 different test suites by type and by team. And we can run them on separate TeamCity agents. And at first you may run into issues with that because suddenly your tests start failing. So you will need to do some changes to make your parallel test reliable. But then you have faster tests. And the last tool for speed I will mention is categories. So I said we split our tests by team. We use category for that. Another category we have is smoke. So we run our smoke tests several times per day, and we run all test suite nightly. Also, we add the browser category for tests, for UI tests, that we want to run on more browsers than just Firefox. Because it would be a waste to run all tests on all browsers, right? Google and LinkedIn, they split all their tests also by which code those tests are related to. So when they change some code, also they only run related tests. So some hints. Now what can we do to make our test reliable? Let's first think of test coverage. Okay, so you write unit tests. But do you write them for JavaScript too? Anybody know? All right. Do you write tests for bug fixes? Because if you found a bug manually, well, it looks like a weakness in your automation and you might want to strengthen it. Also, actually, bugs are quite different and it could be impossible to find some bugs with some tests. So that's why we have API tests, UI tests. But even, for example, UI tests written with Selenium and checking particular parts of the web page might not notice an unexpected unicorn on the page. And this is a true story from Google Apps, after which they started comparing screenshots of previous version and current version. And this could be a great addition to your test coverage. Actually, test coverage doesn't necessarily have to be ensured by automation. Facebook has this policy, eat your own dog food. It means developers are using their development version for their personal Facebook account. And given how much time people usually spend in Facebook every day, how much coverage do you think that gives? Another thing that impacts test reliability is environment. So for starters, what I would do is make sure our test environment is production-like. Not necessarily in resources, I know it can be expensive, but in the whole configuration. So SSL, content security policy, whatsoever. And then there's test data. So creating it every time and cleaning up hurts speed. Maybe we can use existing data. Or maybe some do maintain a database image or a virtual machine. Spotify has this test data service. So it returns data that a test requests. So there are multiple possible solutions, but all of them require creativity, effort, and discipline. And what else requires discipline is actually keeping the test green. And I haven't come up with any better solution here than the whole team prioritizing automated tests. So if there are several failures, maybe a few people can jump at it. Doesn't matter if it's functional test or unit test, not just one poor tester. And this sounds good, but then there are flaky tests, which sometimes pass and sometimes fail, and it's hard to make them reliable. So other times when you deploy many times per day, and you have almost all tests green, but there are a few failures, it might be quite expensive to hold that deployment. You really want to get that thing out. And there are multiple possible strategies here. So Vinted and LinkedIn, they have zero failures policy. But what Spotify does is they say, we can use pass ratio. So if, say, 95% of tests pass, we're good to go. Why I think continuous delivery works, given that you have to cut some corners in testing, is actually possibility to get the fix there fast. But for that, you have to learn about the problem fast. And that you can do by testing in production. And this is great because instead of faking users in some lab environment, you check with real users browsing your real system if it works. But of course, testing in production consists of different ingredients. And the main ones I know are feature toggling, A/B testing, and monitoring. Feature toggling is used by probably all companies that I've looked into. So Facebook and Google, we know they are enabling their features for users gradually. Etsy used this complex configuration file with options like you can see in the slide. And Visma are turning features on or off for all or for particular customers. And it's so common because it's a very effective way of testing. So you enable a feature for some 10% of users, and if everything's fine, then you enable it for the rest. So kind of your users test it for you. But can you then reduce your actual internal testing? I would say, one, you don't want to disappoint those 10% of your users, right? And two, there can be bugs with that feature turned off, or even especially with that feature turned off. So I would choose to test it. And the good way to test it is to do the same in test environment. So you enable a feature for small part of your team, then you enable it for the rest. Not only continuous delivery happens fast from development to deployment, features are also designed quickly. And that's why A/B testing works really well here. So instead of going head over heels trying to figure out if your users would like it one way or a different way, you just enable it one way for half of your users, the other way for the other half. And then you compare what was more successful. This sounds really cool, but actually there are cases when you need to do pre-thinking. Shouldn't be your main design means. Or sometimes it's better to have a setting in the options. So a Slack chat is one good example, or bad example. One day it stopped minimizing the tray. And I found a user forum where they explained some users started complaining they missed messages. But what about other users who were perfectly fine till now and now they hate it? So sometimes A/B testing is great, sometimes letting user choose is better. Monitoring is essential in continuous delivery. First of all, because there will for sure be bugs in production. Testing is just too fast. And two, LinkedIn, and now we are doing the same thing in Visma School, find that it's actually useful to monitor test environment. Already there you can find problems by monitoring. And the first thing you will want to monitor probably is errors. Error logging is common sense, but how often do you look at your logs proactively? Vinted has this awesome solution that when error threshold is reached, they are notified in Slack chat automatically. And this is their team's main communication tool, so everyone sees it. Now, I mentioned that you cannot really do extensive performance tests with the pace of continuous delivery. So why not set up a tool like New Relic or Red Ocean and just monitor the actual real performance? User behavior is good for A/B testing, but also it shows much more, like maybe there are functional issues or performance issues and users suddenly stop using particular feature or your system at all. Why not monitor that? And finally, users give you feedback. So you can monitor, for example, the rate at which support requests come in. Or if you have user forums, you can see which issues your users are the most concerned about. I, as a user, have multiple times run into bugs of Airbnb and Spotify, for example. And I try to find help in their community forums. And I can only say good words about Airbnb. But with Spotify, I nearly quit their service. And what surprised me was that issues with many kudos points, many comments from other users, they were completely ignored. And I will not continue with that story, but the main point is monitoring is a super powerful test tool, and user feedback is part of that monitoring. Now, a few words about the feature. Virtualization at cloud is getting more and more powerful, and it's already used to set up test environments easily, to reproduce some bugs whatsoever. And I've read this interesting idea that testing in the future will look a lot like the Matrix movie. So some users of your system will be real, and some will be virtual users trying to get ahead of those real users and anticipate any issues that those may face. Well, I haven't come that far, but these test techniques already established for continuous delivery, they do look like first steps in that direction. So I hope you found something useful in this talk and can bring back home better understanding, maybe some idea that you can use. Thank you.
Thank you, Aistė. And any questions?
For questions, we have some gifts. Have that in mind. So you probably saw those cards that we were giving, and you can get more full decks. So Sandra will help me, and I am ready to answer your questions.
We have one here.
So my question is, which parts are automated by developers and which parts are automated by test team?
If you're asking about Visma, and even there we have multiple products, we have technical test team, which is testers automating API and UI tests, and developers do unit and integration tests. But this is not necessarily the case. In some organizations, developers do all automation, and it can work. Yep.
So you mentioned that there was sort of like a cultural change that every developer is responsible for their own code. Were there any instances of cover your ass behavior, like writing tests just so that you don't get blamed, and when something bad happens, there's a German word for this that's basically you're particularly happy that something bad happened, not for you. So basically, you're looking for someone to blame. Well, yeah, but my point is that basically, doesn't the enforced responsibility for your code encourage finger-pointing culture, cover your ass behavior, and doesn't that counter the whole agility and agile thing where you have group responsibility for the code?
Oh, it's actually the opposite, or not really related to that behavior. It's more or less more about that if that piece of code belongs to you, you're at risk that if you're out at a bar Friday night and you have to come back to work. It's more about that. So you don't want that, so you take care of that your piece of code is well tested and well deployed. But now that we have this list of responsibilities, it's actually why we came up with that list. Because before there was finger pointing. Oh, I worked with that, but I know he did and he did and he did, so maybe it's not my problem. So it's actually helping. But like I said, it's not always easy. Okay?
Hi, just wondering, how big is your development team and how big is your testing team? And the second question, how many projects are changing your product at a time?
All right. So I'll start with the easier question. Our development team is now about 50 people, consisting of 7 teams, each of them having like 6 developers and 1 technical tester. So I hope these numbers add up. And the second question? So how many projects are changing for one product, you mean? That's a question I'm not able to really answer, because normally what we do now, where I work, is a project to implement a new product. So no changes. Also, we have products that we have bought or started developing. So we don't even call it a project. It's product development. At least this is what I know. Yeah.
One of the main questions is, are you still using Spotify?
That's an interesting question. I have quit right now, but just to try Google Music, and then I will see if I come back or not.
But they have the new running feature now, and the serious one. I'm not from Spotify, by the way. The real question is that I almost forgotten. You and the guy before in a different presentation are mentioning unit and also integration testing while speaking about testing process from the perspective of the tester. And what I would like to ask, how much, if at all, you are involved in unit testing and preparation of unit tests and integration tests? Like, are you working with developers side by side, if at all, and how much are you involved if you do?
Less than I should. Because what I know, but what I'm not doing as I think I should, is actually really know what is covered by unit tests. And I shouldn't really differentiate much between unit tests and integration tests. That doesn't concern me much. I just know for a while we had a difference when we run each of those. Not anymore. But I should know that in order not to duplicate the same in my slow tests that I write. This is why I should know that. Or maybe ask developers to add tests so that I don't have to write them, because it could be covered with unit tests.
I have a two-part question as well, because that has become a habit. So the first part of the question is, how useful do you find automated UI tests? How often do they bring up results? And the second part of the question is, do you have a ratio for automated UI tests? How much of them, how many of them, what is the percentage against unit tests, integration tests, and manual testing?
All right. I have the tendency to forget the part of the question if it's long. So the first part was?
The first part was, how efficient, in your opinion, are automated UI tests?
Okay, automated UI tests are the ones that find the problems easiest. The problem with them, though, is that so many of them fail that we are not efficient in looking at them often enough. But other kinds of tests that are lower than UI, they cannot simply find the bugs that can be found through UI. So we do need them, but we only write them for happy path scenarios and for UI validation, basically. So we try to keep this pyramid. You remember from previous presentation, maybe? So we have much less UI tests than we have API tests. API tests are written also by testers, and there are much more of those than the UI tests. And those are very effective, and almost all of them pass. Yeah.
Well, that basically answers two questions.
Yeah.
Okay, more questions? No. Sorry.
We still have, I think, like 8 decks or 4? 2? Okay, they are bigger, so 2.
So in case of redesign, let's say you have a complete UI overhaul. Do you rewrite all of the UI tests as well, or do you just wait for them to fail somewhere in the future and just fix on demand?
We rewrite. Once we had a very sad story when we rewrote tests too eagerly. In fact, they were showing that some functionality went missing, and we thought it was supposed to be missing, so we removed the tests. So that's a sad story, but we learned from it. It was not about UI, it was about functionality. But that's just to add to the answer that you shouldn't remove tests too quickly. But yes, we do rewrite them, of course.
Okay, any more? Here's one.
Very practical question. What is the percentage of the unit test coverage you think is the best? Maybe in your project or in general, what's the practice in Visma?
Well, I don't think I can come up with a number to that answer, but what I noticed is everyone knows 100% doesn't mean anything. So at some point we get comfortable with having 60%, for example, or 70%, and we say, well, it doesn't mean anything, it could be quite good. But then when we speak to each other, we learn that we are not covering, for example, JavaScript already for a while, and we thought we were doing that. Or we are not covering bug fixes, maybe in some exceptions only. So actually the 70% already shows the problem. We could find it also by looking at a number.
Okay, one more deck here of cards. So last question. Anybody? No? Oh, there in the end.
Hi, my question is, you covered a lot of things in testing for very big projects with big teams, etc. And my question would be, what is the best in Parrot principle testing environment for a small team without no dedicated tester? What top things would you choose for that? Unit tests, UI testing, or what should be done by developers? What shall be done by product owner or product manager?
Okay. If I had a small team, I wouldn't concentrate picking only one type of test. So, for example, you say our QA will do manual testing and developers would add unit tests because this is what developers do. What I would try to do is developers writing those tests that they think will give the most value, going all the way up to Selenium, but trying to keep the ratio of tests effective, of course, so that they are not slow. But then developers would automate all kinds of tests. Could be API, UI, unit, as long as they find them useful. Also, I don't know what that project would be, but maybe some things you can solve by monitoring or using your system yourselves. I was once working with eMaxima before it turned to Barbara LT, and I really loved the idea of using it myself, and it would have been nice production testing. So, yeah. Could be different techniques. See what you can do with your people, but don't concentrate on choosing only one type of test.